How you doing today? I'm M. James Short. I'm a game developer here in Austin, Texas. I release games as NEWMARK Software. I've released a couple mobile games in the past, and I'm working on some console games currently. Today we're going to be talking about how games are constructed. This is week 1 of our 6-week series on video game development. So this week we'll be talking about how games are constructed. Next week we'll be talking about starting your game and actually implementing your game into an engine. Our 3rd week we'll be talking about game interactions and how the different objects and systems of the game work together. Our 4th week we'll be talking about level design and really investigating levels and space and how to engage your players through the spaces that you design. The 5th week we'll be talking about programming languages, really taking the game mechanics and the logic that we talk about in the early weeks and writing it through syntax of code. And our last week we'll be talking about idea to completion, how to take the idea that you came up with as a gameplay designer and implementing it yourself and releasing your own game. What we're going to help you do is learn how to do the gameplay designing and then to do the gameplay programming to take your ideas and actually implement them into an engine with code and then be able to play them. Have you ever seen this game before? It's Super Mario Brothers. Pretty famous, most people know about it. And we're going to use it as an example to talk about gameplay mechanics. And today we're going to do a lot of focusing on gameplay mechanics as we talk about what the gameplay designer does. So today when we talk about game mechanics, we're going to start with an example from Super Mario Brothers. So Super Mario Brothers has 3 game mechanics that are very, very simple. The first one is moving. So Mario in the game can move back and forth. The second one is jumping, which is what we're going to focus on today. So when the player presses a button, Mario jumps into the air. The third is running, so there's normally another button used to speed Mario up. Those 3 mechanics make up the whole player's interaction within Super Mario Brothers, and it forms the basis of the game. Everything else that happens within Mario Brothers, jumping on a Goomba's head, busting a brick, jumping on a flagpole, they all use those game mechanics to create the gameplay. And that's really what the definition of game mechanics is. So a game mechanic is the method by which the player interacts with the game, thereby creating the gameplay. So what I want you to do now is I want you to think about a game mechanic that you've used recently in a game. So write down a game mechanic from a game that you've played recently, and then we'll discuss it some more. So in our example, I'm going to focus on Mario. I don't know what you've come up with, but I'm going to keep going with the Super Mario Brothers example. So if I was the gameplay designer for Mario, I would write down a very simple idea. When the player presses a button on their controller, I want Mario to jump into the air. Very, very simple. I would take that idea and then I would hand it to my gameplay programmer. And I would say to them, hey, we need to figure out a way to make Mario jump into the air when the player presses the button. Now remember from earlier, it's the programmer's job to take that idea and implement it into the code in the game engine using game logic. So we've done the role of the designer so far. That's checked off. We can move on to the next part, which is actually taking that idea and implementing it into game logic. So now that we've completed the step of the gameplay designer, we've created a game mechanic that we want in our game, we're going to move it over to the gameplay programmer. Now if you remember, the gameplay programmer's role is to take that game mechanic and implement it into the game engine using game logic. Game logic refers to the internal mechanisms of a game that are needed to perform all the tasks of the game engine and make the game work. If I started thinking about, from a game logic perspective, what my game designer asked for, where he wants the player to press a button and Mario to jump in the air, it would look something like this. If a button is pressed, Mario jumps. Really, really simple and only 2 sentences. So that is the first thing about game logic that we have. It's taking a problem that's presented by the gameplay designer and thinking about it in a way of how we can structure it in our game logic inside the game engine. For our second activity, what I would like you to do is take the earlier game mechanic that you wrote down and write 2 simple sentences that describe the game logic of your game mechanic. As we talked about, when the designer has a very simple idea. When the player presses a button on the controller, I want Mario to jump in the air. Now we've taken that idea, and as a gameplay programmer, we've written down, if the button is pressed, Mario jumps. And now we're going to talk about game structure. Game structure is a defined set of instructions, or statements, that your game engine reads to make your game logic work. The most easy of those, and that's used a lot, and that we'll be using a lot in the next couple weeks, is called an if statement. An if statement is the most common instruction that we'll be working with, and it looks like this. So if, expression, and then statement. Now you might say, well, what's an expression? Well, an expression is game logic that the game engine needs to compute and determine the result. So for example, It's something that we are telling the engine to look up, but the engine doesn't know what the result of that is yet, so it can't process it. It needs to go figure out the result, and once it does, it can evaluate that result and then make a decision based on it, and then do the next statement that we told it to do. So, an example of that would be, if we go back to my original game mechanic that I've turned into game logic, if the button is pressed, Mario jumps. The if statement for that would look a lot like this. If button is pressed, Mario jumps. Now you see I'm using the same very natural language when I explain my game logic, but I'm starting to format it a little bit differently. I'm adding things, parentheses, to the game logic to separate things, so it's a little bit more readable by things that are other than humans, like maybe my game engine. So if we compare the two things, on the left here we have my original statement. We have if the button is pressed, Mario jumps. And on the right is the format for an if statement. You can see how they're very, very similar. So for our third activity, what we are going to do is we're going to take our original game logic that we wrote, and we've kind of moved down through the pipeline, and we're going to update it so that it reads like an if statement. We also need to ensure that our expression is in parentheses. But there's one more thing that we need to get Mario to jump. Mario doesn't know how to jump until we make him jump, until we program it and tell game logic, hey, this is how Mario needs to jump once I tell you to do that. To do that, we're going to use what's called a function, and that's our third of 4 things that we're learning today. So a function is a set of defined game logic that is executed when called. So before I write my if statement about Mario jumping, I would have had to go off and create another set of game logic that defines what happens when Mario jumps. Does he move 14 pixels in the air? Does he move 30 pixels in the air and 14 pixels to the right? All of that game logic would be called in a function, Mario jumps. But there's different types of functions. So the first type of function might have inputs called arguments. For example, Mario jumps, and then we pass it an argument. Maybe when Mario jumps, we only want him to jump 80 pixels in the air. So we would say Mario jumps, parentheses, 80. Some functions return outputs back to us based on our inputs that we put in. For example, get Mario health. When we ran that or called that, it would come back and say, Mario has 3 hearts left. And finally, some functions just execute. In the case of today, that's what we're going to be referring to. In this case, Mario jumps. For our fourth activity, we're going to update our original game logic again so that our if statement contains a function. For this, we're going to keep our function named a specific way. So we're going to start with a noun, we're going to go with an underscore, and then we're going to put a verb after it. So whatever's in your game logic, use your noun, and then say what you actually want it to do. So as you can see, I've updated my original if statement. So now it says if the button is pressed, which is what the game engine is going to go figure out, then Mario jumps. But there's one thing that we don't actually know here. The game engine doesn't know what button needs to be pressed. I've told it that if the button is pressed, Mario needs to jump, but I haven't told it what button to use. To define that, we're going to use something called a variable, and that's the last thing that we're going to work on and learn about today. So a variable is used to store a value that may change. First, you give the variable a name, and then you assign it a value. So in my original statement here, I say if the button is pressed, Mario jumps. But as I stated, I haven't told the engine and the game logic what button needs to be pressed. So to do that, we're going to create a variable. So I'm creating a variable called underscore gamepad button. Then what I'm doing is I am assigning a value to that. This is called declaring. So in this case, when a user presses the A button, I want that to be what the engine references the gamepad button as. Then after I've declared my variable, I'm going to update my original if statement and put gamepad button instead of just button, so that the engine knows that when it reads gamepad button, it's actually the A button that it needs to check. So when I run this if statement inside my game engine, let's go through what's going to happen. So first, the engine's going to look and see if the gamepad button is pressed. So it'll look at the controller. If that gamepad button is down, then that's true. It's going to come back and my result will be, yes, the gamepad button is pressed. I need to do what you asked me to do. Then it will perform the function that I originally told it to do. Mario jumps. And in this case, Mario will jump on the screen. So let's go back to your game logic and add variables in to your original game statement. So update your original game logic so that your if statement contains a variable. Add the variable above your game logic. This is called declaring. Let's step back to where we first started off. The gameplay designer came up with a game mechanic that they wanted the player to interact with. When the player presses A on their gamepad, they want Mario to jump into the air. We then put on our hats of the gameplay programmer and thought about that game mechanic and how we could implement that into our game engine using game logic. And this is what we came up with. Gamepad button equals A, and then if that gamepad button is pressed, so the game engine will go and evaluate that and make a determination if that's true, then Mario jumps. So that kind of shows you how you can take an idea and execute it using game logic inside your game engine. So we completed the role of the designer and the programmer now. As the gameplay designer, we thought of a mechanic, we thought about how we wanted it in our game, and as the programmer, we took that gameplay mechanic and implemented it into our game engine using game logic. Between now and next time that we meet, I'd like you to pick something from your everyday life and think about how you would make it happen with game logic. When we come back next time, we'll talk about that, and we'll start implementing our game logic into a game engine and actually playing our game together. Thanks for watching. We'll see you next time.